Isolates. Isolates used in perfumery are single components, or sometimes mixtures of them, separated from essential oils by three main methods: fractional distillation, cooling, selective solvents. Isolates. Fractional distillation. Fractional distillation is used to separate citral from lemongrass oil, eugenol from clove oil, according to each component's evaporation characteristics. Essential oils are complex natural mixtures. Each component of the mixture in an essential oil is an aroma chemical with its own unique evaporation characteristic. In perfumery, fractional distillation is used for refining essential oils or separating individual constituents, isolates. The equipment is a combination of a still to warm the material and a long column above the still packed with beads. The beads may be glass, ceramic, or other non-reactive material. As the raw material to be fractionated is warmed in the still, the smaller molecules tend to evaporate first and move easily and higher up the column, followed by medium-sized molecules and then even larger molecules. As each material gets away from the warmth of the still, it starts to condense on the beads and dribbles back down to the point at which the warmth once again lifts it up, again and again. This lifting and dropping back down slowly puts each component aroma chemical of the essential oil at a different level or band in the column. This is happening simultaneously with each component aroma chemical of the mixture within the essential oil. Having reached as high as they can, they drop back and are warmed again. Now all that has to be done is the column is tapped at each level to remove the target aroma chemicals. Some preparation of the material may be made to facilitate better separation. Geranium oil, for example, is saponified, that is, reacted with an alkali to produce a soap prior to fractional distillation. Fractional distillation is also used for refining alcohol. The terms double or triple distilled refer to this process. It is also used in the oil industry for separating the different fractions, parts, of crude oil into butane, pentane, hexane, heptane, octane, nonane, decane, undecane, dodecane, benzene, xylene, paraffins, and heavy oils and greases. The taller the fractionating columns, the better the separation. Hence, oil refineries have columns that may be 30 meters tall. Cooling. Some of the components of essential oils are solids that, if the essential oil is chilled, will drop out of solution. Then all that needs to be done is to separate the solids from the liquid part. If peppermint oil is chilled, transparent glass-like needle crystals of menthol fall out and settle on the bottom. If cedarwood oil is chilled, then a solid mass of cedrol crystals form. Isolates. Selective solvent extraction. By using two solvents that will not mix together, we can introduce an essential oil and the components of the oil will move to the solvent that they can dissolve in. An example of this is the removal of terpenes from citrus oils to produce a more stable, concentrated, alcohol-soluble, terpeneless oil for fine perfumery. And a byproduct? The terpenes from the oil for use in cheap household fragrances. For example, two solvents that will not mix together, methanol and pentane, are put into a flask. If we then introduce orange oil to the terpenes, mostly dilimonane, which makes up 98% of orange oil, will move into the pentane, and the remaining components, including the really strong orange aldehydes, dissolve in the methanol. All that needs to be done then is to separate the two mixtures. From the pentane and terpenes mixture, allow the pentane to evaporate to leave dilimonane. From the methanol and orange aldehydes, evaporate off the methanol to leave a terpeneless orange oil.